So let's take a look at this tuning fork lab. So much of what we do is kind of like bookwork, and it teaches you a process is basically what you're learning. But the reality is usually in real life you don't have textbook examples. I thought I'd give you this sound wave that looks like a sine wave, but it's like a real life sine wave, not just something that matches up on the unit circle perfectly. And let's take what we've learned from our bookwork and use it on a real life sine wave. Our goal is going to be to find the equation of that sound wave, and we're going to create it by using a tuning fork. Secondly, we'll use our equation to replicate that sound and create a musical instrument that has that same sound. The tutorial today is really just on goal 1. You got to be able to write that equation if you have a sound wave. So let's look at some examples. Instead of looking at a sine wave on a nice unit circle scale, I just made a sine wave and put it on a random scale, just 0 to 5 kind of thing. If we look at this, let's see if we can figure out the amplitude, the period, the phase shift, and the vertical displacement given these values on this sine wave. Now, this is still going to be a pretty nice looking sine wave compared to what we're going to do with our tuning fork, but I thought we should start here. Let's go through the list of 4 features that we need to figure out. First of all, the amplitude. The amplitude, remember, is half the distance from your min to your max. It's half the height of the wave. If you look at this, we go from a -1 and it makes it all the way up to a 5. Well, that's a distance of 6. Half of 6 is 3. That makes our amplitude 3. Now this one was an easy one just to look at and see what it was. Do you think you could figure out how to get from here to here and turn it into a 6 so that we would know then to do half of that? How would you get to 6 from, basically I have a 5 and I have a -1? Think about that for a minute. We'll come back and summarize. The period. The period tells you how long it takes to get one complete wave finished. We've been practicing working with something off the unit circle. Thus, we're looking at a sine wave that does this kind of a thing. The problem with a real sine wave is finding this spot right here in the middle is a little bit tricky to pull off. If you can see this, the middle of this is somewhere in here-ish, and so to find that exact spot is sometimes tricky. Recall that a sine wave doesn't just magically create this shape. It does continue on. You know, it's going to keep going, and this is going to keep going this way. So to find a full wave, sorry, I was trying to make that dotted, but it looks kind of ugly, but that just happens to be, that is the piece that we typically would use because it works nicely with our unit circle. But really, any chunk of this wave could work. The chunk I'm going to use instead would be actually what we would look at typically with a cosine. I'm just going to go from peak to peak. And I choose that piece of the sine wave just because it's easy to pull out peaks instead of middle points like this. When I look at my graph then, I'm basically going from one peak to the next peak, and I'm trying to figure out what that distance is from one peak to the next. Doesn't look like it comes out nice. I could estimate that, and I could call that probably, if I had to guess, I have one full unit here, but I've got a little bit there and I got a little bit over there. Maybe we could call it 1.5 is what that would end up being for a period. So I would just write 1.5. But recall that the period is not really what we use for our equation. Remember that the period is equal to 2 pi over b. I really need the b value so that I can solve, or so that I'll have a value to put into my equation. In my calculator then, to solve for b, I'm just going to take 2 pi and divide it by 1.5. I get a b value of 4.19. Now on your lab, you are going to need to keep all the decimal places there. You're going to have such minute numbers that those little decimal places are going to be important. I'm just going to go to 2 decimal places because I'm going to run out of room doing that, but I gave you plenty of room on your lab sheet to give me all the decimal places. The phase shift is the place, and this does have to kind of look back at a sine wave. Let me redraw my sine wave. A phase shift really is this spot where the sine would start, where it's at 0 headed up. I do need to find that middle of the road spot where it starts at 0 heading up. So I track this, and I start right here at 0, and I'm tracking my wave to the first place I'm at the middle. Now I say it's 0, but obviously we're not, our equilibrium isn't the x-axis, so I got to go up here to where the equilibrium looks like it kind of would be-ish right here. It looks like it's about the middle of the graph, and it is there headed up. It looks like, and that actually worked out really nice for us, it looks like we shifted our wave 1 unit to the right, and now that's where we're at 0 headed up. That makes for an easy C value. Our phase shift is 1. Now the vertical displacement has to do with what's going on vertically as well, but don't get it confused with amplitude. The vertical displacement is how far the graph went up. Well, typically the equilibrium is supposed to be right here along the x-axis. You've got to figure out where the equilibrium really is. You're looking for kind of where the middle of it is. Well, if you think about it, if this is at -1 and this is at 5, what would be the middle between those? Well, it's going to fall at 2, which worked out good for our phase shift right there because it was right there at 2. The vertical displacement is 2. Now you have to think about how you found that because, again, it's not going to be pretty on your tuning fork lab. You're looking for the middle of those 2 values, -1 and 5. I want the middle of that. So I probably am just going to find the midpoint. I could just add 5 and -1. That would give me a 4. Divide by 2. There's my 2. Basically finding the midpoint. Now, the last thing that you're going to do once you find all that information out is you're going to come back and you're going to write your equation of your sine graph. So it's going to be y equals, you put your a value, sine, then you put your b value. Now when you type this in your calculator, it forces an open parenthesis right there, and you can't squeeze your b value in there. You're going to have to do nested parentheses. I'm going to have sine, then I'm going to put my b value, 4.19. Then I'm going to open parentheses again and do my x minus c value, close, and then close again, and then do your vertical displacement. Now, ideally, I don't have a way to do it on the video, but ideally you type this into your y equals, and it's going to match up perfectly with the graph that you're going to see on your calculator. Now that was an example with the numbers being nice where I could just kind of talk through it. Let's go ahead and summarize that so you're sure that you're doing the right thing each time. For the a value, that was our amplitude. Remember that that's half the height of the wave. If I can find this distance here, I know that it's going to be half of that distance. To find the distance from 5 to -1, I would have just taken 5 minus -1. Change. Oh, that distance is 6 units. And then divide by 2. Because I want half the distance. That's where I got my 3. Now let's write it so we recognize that it's not going to be these nice pretty numbers. You're going to have to find, and it really doesn't matter which one of these points you pick, but you're basically going to be tracing your graph, and you're going to find this. I'm going to call it x1, comma, y1. And let's call this one x2, comma, y2. You're going to trace your graph and find those 2 values. Now I'm going to come back and erase this and write it so that you can see what you're going to be doing. Notice that the a value has to do with amplitude. It is all about the y values. The x doesn't matter. I'm going to take my y1 value and I'm going to subtract my y2 value. Now there's a very good chance that your y2 value is going to be negative, like this one is, and so it's going to end up minus minus, which is going to end up being a plus. But then you're going to have to divide it by 2 because we want half that distance. Now let's talk about the vertical displacement while we're talking about the amplitude, because they are very, very similar. They both deal with how high and how tall that wave is and where it falls, kind of thing. If I wanted to find the D value, I want to find the middle of these 2 points. Now don't get caught up in the actual midpoint, because I don't really want, I'm not looking at the angled line from one point to the next. I'm not looking at that. All I want to know is the distance, the vertical distance between the two. I'm only going to be using the y's, still ignoring the x's. And to find the middle of two things, it's like finding the midpoint. I would add the y's and divide by 2. See how similar that is to the a value? You got to kind of keep track of what it is that you're looking to have happen there. All right, the next thing. The B value, that's the period. Now, on the previous example, we basically went from this spot to this spot. And we measured out how far that was. It came out nice, so we could figure it out. We thought it was about a 1.5-ish. We have to be more specific than that. We have to actually look at the values, look at those x values. But here's the other thing that you're going to find. So I'm going to add something in here that we didn't talk about last time. Oftentimes what will happen is that you'll pick this wave right here, and you'll find the period from here to here. And that's one full wave. But it'll look great on that wave, but by the time you've made numerous waves, it's way off down here, or a little bit off at least. It would be smarter of us to find the average period. Now you're going to have a whole lot more waves than what this one shows. I really only have a few waves, but I would go to the very last wave that's on your graph. I'm going to call it X3, Y3. You're looking for a horizontal distance this time. Now I'm only concerned with my X values, not my Y values. And I'm going to find out how far it is to get clear down to that very last wave and find that distance between those x's. Well, to find that distance, I'm going to take my x3 and subtract my x1. But that's not really one period. That's numerous periods. Now, you have to count how many waves created that. So if I start here, there's one wave, there's 2 waves, and that's all I got. You're going to have more like 5 or 6 waves to be measuring. And if you can get a good average over 5 or 6 waves, your period's going to be pretty close, like dead on probably. If I find this distance, then I'm going to have to divide it by how many waves I have. Now keep in mind that this right here actually is going to equal the period. This is not going to be the B value. So that's separate than the B, really. And you find the period, and then you set it equal to 2 pi over B to go find the B value. Those are different things. The last thing that we have to figure out is the C value. And this is not going to be something that's sitting there super nice for us, especially like it was in this example where you could see that the middle of it was going to fall right there on that 2 line, because that was your equilibrium, and there it was right there at 0 headed up on that line. That's not going to happen. There's going to be vertical displacement, and you're not going to be able to really identify where that's going to fall. The only way we really have to find this, we can't really trace. Here's the problem with tracing, is it's tracing a scatter plot, and it's going like this, and it's popping from here to here to here to here, and then it's going to hop over the spot you even want. So tracing doesn't find our phase shift very well. A better way to find that phase shift is going to be to recognize that it is that this x value here that we're shooting for is going to fall between this x value and that x value, because that's right there falling along the path of the wave, and this should be kind of the middle of those two spots. If we look at this x value and that x value and average them, we should get a decent place for this spot where it's at 0 headed up. Which means I got one more thing that I have to find. And sometimes, you know, these points might be used more than once. I'm just giving you an example. I would have to go find this value, which is going to be x4, y4. And if I look at this x value and this x value up here and average them, that means I'm going to be taking the x4 number that I find and adding to it the x1 value and then dividing it by 2 to find the average of them. Now, I've given you kind of these notes here, but I really don't want you to get caught up in x1s and y4s and all this business. I really want it to kind of make sense in your head what you're doing. Don't feel like you have to go label everything x1, y1, and like I have labeled it here. I've only done that so I have something to reference as I'm writing down the concept of what you're doing. If you can just remember, oh, my period is going to go from this wave to this wave, and find the average of those, recognize the period is a horizontal thing, use the x's, or recognize that when I'm finding my vertical displacement, I'm looking at y values, and I just need to find the middle of those y values. Don't get caught up in x1s and y1s. I did think, I'm not going to go through a whole nother example, but I did think that it would be nice for you to see really what you're going to be looking at. Yours is going to be something like this. You're looking on your graphing calculator because you'll collect this data, and that's what your sine wave will be. And you're going to be tracing along this wave, and this spot right here is like going to be your x1, y1. And then if you were going to do the period, you'd go way out here to the end and find that value. And this is what it's going to be looking like. So here's going to be another point that you're going to want when you're trying to find your phase shift. And you can see right here is the spot where it's at 0 headed up. But because of the vertical displacement, I think the middle is more here-ish, and we don't know for sure where that's at, which means you're going to take this x value and this x value and average them, and then you'll know where the middle of that kind of is. But just so you can see, you're going to trace this, you'll look at your x and your y down here, and it ain't going to be pretty. Keep all the decimal places there. All right, hope this helps. Good luck.